Hello, Flat Earth researchers, debaters, and debunkers. This is a quick follow-up to my previous video in which we looked at a few photographs on this website, MC Tun, claiming to be evidence of left-to-right curvature on the horizon. So in this follow-up video, we're going to look at three things specifically. Firstly, how the appearance of curvature was deceptively done with this photograph and these two here. Another factor in the deception was this compression that was done to the above photograph, and we'll see what compression does to photographs and what it reveals about these so-called straight lines used as a level reference in these photographs here. So that's the second thing we're going to look at. And the third thing we'll talk about is how this demand from flat earthers for left to right curvature really is a straw man argument. Actually, well, let's just talk about that right now, and with the understanding that the reason we demand that you go and look for curvature left to right, given this idea that in front of you we have the start of curvature at the horizon at a given distance depending on our height, then, well, logically, if you're going to use that argument or that theory and claim that this is reality, then in reality you should see the same curvature you're talking about in front of you to the left and right. But of course we know that this is never seen. We've all tried to do this because that's what scientific inquiry really is. We should be studying what we see and really thinking about how we are seeing it, and especially the instruments that are being used to study it. Now, it's also worth pointing out right now that really cameras are not measuring instruments. So we're always going to have issues such as lens distortion in various forms, which will lead to this kind of appearance. So, the thing is, if you think about this photograph and then you first of all realize that it looks like this because it's distorted, and then secondly, well, okay, if you're going to use this as proof of seeing left to right curvature, then just try to envisage taking three more photographs. Let's say this was facing north, and then you take one facing east, and then south, and then west. Imagine that you can see the sea all around you. Do you really expect to see this hump of curvature to the north, with it going down to the left here and down to maybe down on the right here, and then you turn 90 degrees and you take another shot and you see another bulge of curvature, and then you turn another 90 degrees and you see another bulge of curvature, and so on? If you just imagine your photographer in a circle of these photographs around him or her, seeing this bulge in every photograph with the curving down left to right, then of course you end up with this 360 degree view that looks like we're on the inside of a flower looking at petals. So again, this isn't reality. That won't, if you just take this particular photograph, for example, take it a step further and compare it with what you would expect to see or should see with a 360 degree view, then again, it's impossible. It's not what we see. We don't see. There isn't any way that you would ever see bulges of curvature left to right anyway, and there isn't any curvature in front of you either. This is the whole point we are trying to make when we say go and find curvature left to right, because we know already that just because there's a calculation that tells us if you're 2 meters above sea level, the horizon is about 5 kilometers in front of you. We know that doesn't mean that the water is suddenly curving down and away from you just after 5 meters, depending on your height. It shouldn't depend on your height, because ultimately we're supposed to be talking about what is a globe of a fixed diameter or circumference or whatever. It's a fixed geometry. So your height above the surface doesn't determine the extent to which you would see curvature at all. It wouldn't, would it? If it's fixed, it's fixed. If it curves in all directions, then it curves at a certain rate, which of course we know is supposed to be 8 inches per mile squared, or whatever you want to do to translate that into a metric or whatever. You just don't see that. It's not seen because it doesn't exist. It doesn't exist left to right. It doesn't exist in front of you. And so again, you just ask yourself: is there any way of knowing this, of confirming this? If that's the claim, that the horizon is where the Earth starts to curve away from you, down and away from you, then how can we prove that? Well, you can't, because it doesn't exist. It's physically impossible. So it's that's this whole left to right curvature thing is a straw man argument, and of course, really. That you should have stuck to your guns there, really, and said, well, it's locally flat. So, without further ado, let's go back to now look at how this appearance of curvature was deceptively done. With this photograph here, I'll just show you this in GIMP first to show you what the problem was, and then we'll see a video that demonstrates how it was done. Here I've put a guideline across what was supposed to be a level, straight piece of wood, to then see if there's any difference between that level and the horizon. Of course, this photograph appeared to reveal that there was a difference between the top of the board that was placed here and the horizon. But of course, that is, as you can clearly see here, if I just try and zoom in a bit more, was because, as you see this yellow line I've put across this guide, there's a gap above the board there. It comes down and then it goes down below the top of the board. So while this yellow line is straight and horizontal, the board obviously wasn't. And this, of course, changed our perception of the horizon and made it appear to be somehow kind of sloping, I suppose, really. Anyway, have a look at this video by Execrate, a good friend of mine, Andrew, in New Zealand, who's done an excellent job of demonstrating how this was done. So Andrew immediately saw what I was getting at in my previous video, and he's come up with this demonstration by simply putting a camera on a tabletop and then drawing a yellow horizon line there at the end of the table, and putting up this spirit level against the horizon. And of course, when you twist it, then we see this difference between either end of the spirit level and the flat horizon. If the object, including this ruler here, is flush with the camera, it's directly in front of it and not twisted, or is a parallel line to the horizon, then it will be flush all the way along. But the moment you put a slight angle, bring one end towards you or push the other one away from you, then you create a gap on either side, or a narrowing gap as you go along the edge. So that was how it was done. So it's quite funny, really, that globies like to talk about flirspective in a derogatory way, but they certainly understand how to use perspective to their advantage when they want to be deceptive and make claims of curvature. Now, if we go back to these two photographs taken in Ibiza, I believe, which were on the MC Toon website as evidence of left to right curvature, we'll see that we had the same issue as was demonstrated in Andrew's video just now, where we had these two pieces of metal supposedly being level and in line with each other, which created this apparent decreasing gap on the left to the horizon, and then on the right an increasing gap. But we can see from this guideline that I've put in that these two pieces of metal were not lined up. Yeah, you can see that there's also an increasing gap here. So they weren't quite straight, which was part of the problem. The other issue is distortion, lens distortion, not only barrel distortion, but various forms of lens distortion, which Andrew has also done a very good video about. So I'll put a link to that one in the description as well. And then we had this cropped, compressed part of this photograph to show this accentuated curvature or appearance of curvature against these apparently straight lines. So a couple of things happen when you compress a photograph. What you have to do is you have to reduce the number of pixels across the image. So for example, this image is a good size of more than 4,000 pixels across and 3,000 vertically, but in order to get that squashed image, then you have to basically reduce the size to about 150 pixels width-wise, and of course maintain the height there. So we can see here with this compression just how wonky everything was. Remember that this is all that was shown in the photograph, but if we zoom out a little bit more, we see that many of the other objects in the photograph that were supposed to be straight don't appear to be straight here. And this is basically what's happened, is it has accentuated the lens distortion. These might well have been straight, but we have this lens distortion that's been drastically compressed, and so a whole bunch of pixels have been taken out. So instead of this kind of slope, we now get this curve with the compression. And as you can see, there's all sorts going on there. So the table is off whack, and the plinth here, if you like, and that's as I said, not only they could be straight, but part of the problem is the lens distortion. So maybe you want to take note of how much the curvature appears to be here. These bits still seem fairly level, but what we can do is we can bring a guide down and we can see that, for example, I can zoom in here, this one has come down a lot lower than this one. We can bring more guides down, and you can see big differences between the distances here on either side. So it is very warped and out of shape. So especially down the bottom here, we can see was it level and then it's been distorted by the lens, or was it a bit of both? Frankly, it's difficult to tell, but it shows again that a camera is not a measuring instrument. We don't use cameras for measuring level. Our eyes can do a very good job, but of course water itself is the ideal measuring tool. It's so these optics taken through various lenses. Well, in science, the instruments that you use to measure something with have to be very accurate and very precise, and they have to be specifically for measuring whatever it is you want to measure. So photographs are not measuring devices. But let's keep this apparent curvature in mind and move on to a squished version of this photograph. So we had this photograph where this is not in the center, but the horizon is almost in the center. But we have this squished version now, and we can see just how much distortion was going on here with these apparently level pieces of metal. They are very much distorted, so this has all become distorted in a different way. And here we have, in this case, even though the photograph was facing the same direction, we have this apparent curve down to the right here. So again, this is a mixture of lens distortion, maybe the camera turning slightly, it could be a fraction of a degree from this straight on, looking straight ahead at the apparatus, various variables. And of course, as I said, if you're going to be scientific, then the tools must be specifically for measuring what you're supposed to be measuring, and you must make sure that they are very accurate and that they don't distort the results. That's not science, is it? So that's that, really. You can see for yourself, and again, this on the website, you're invited to go and download these photographs yourself and check them out, but it just shows that we were presented with this apparent curvature, but not in any way scientifically verified or scrutinized. And ultimately, even though this person might have tried very hard to set up a decent experiment, it really has shown that either they, the important factors about what's being measured, how you're measuring it, are not being properly studied or considered or taken into account. So yeah, that's another foray into the fallacies that are being promoted by these guys. Thank you very much.